Hello and welcome. My name is Boris Brodsky. Today we'll show you how you can write cool tests with Xtend and some frameworks that's written for Xtend. First, we will get a look into conventional testing, automated testing, and problems that we have with it, and how we can tackle this problem with new technologies, and there will be a live demo at the end. So let's start. And first, let's ask me a question. What is the main problem of writing JUnit tests? And it looks like no one wants to talk to me, so I answer it myself. Writing tests is boring. So imagine you just finished some use case, and you want to commit it to source code repository, and that you have this nasty thought. Actually, I have to write some tests. So you know this? This means that you have to go back and start all over again. You have to rethink all your use case, and your tests will be more complex, or may be more complex than actual implementation. So that's not good. But we have another problem. We have the next problem is that watching running tests is demotivating. And it's even more demotivating if you don't have decent internet access. It might be other way, of course, like we just rerun our tests if we want to read some article, but normally it's not a good thing. So we don't run our tests as often as we should, and we end up with broken tests in the repository. And having this, if we change something and run our tests, and tests do fail, we don't know for sure if they fail because of our change or they just was broken already. So the test becomes less value, and this even decreases our motivation to write new tests. So why we can't actually sit down, take the time, and fix all the tests? That is because of our third problem, that fixing broken tests is annoying. Yeah, you not only have to fix a test that is not written by yourself, but you also don't know which change actually broke this test and when. So you need knowledge about the entire system and a lot of time. Can we do something about all this? Yes, we can, of course. And our entire goal is to make writing tests fun. And first, let's see how we can reduce complexity of our tests. So we can use test first. This is, as already mentioned, if you write your test first and then you implement it, you end up automatically with a simpler test and with a design that is better testable. But we can also use modern languages, modern frameworks and test techniques to make writing tests easier. In order to improve performance of our tests, we should write less integration tests and a lot more unit tests. And we will show in a minute why is it so. And we can also use Jenkins to outsource test runs. And we can also make it going a step further and configure our Jenkins so that each commit that we push to the repository gets checked prior to it gets published. So if you try to commit something that contains broken tests, you get it rejected from the Jenkins, you have to fix it, and only then you get your commit into the repository. We can also, so going back to our first problem, this all points actually improves motivation for writing tests, but we can also add gamification, for example, like code coverage games and challenges to improve it even more. So let's see how we can make writing tests cool. And that's our goal. So first, I show you different types of tests. First is an integration test, is most prominent, I think. You have, so this is all an example of Java enterprise application, but you can apply it to almost any system and any type of application. Here we have application server with our modules deployed, and it's connected to database, and we run our test in a separate JVM. First, we make a bunch of calls to prepare our test. Then we call some component that we want to test. It hits all the external and internal dependencies and finally gives us the result that we can check. And this, of course, very slow. The opposite of it is unit testing, where we first mock away all the dependencies, so we have only the code that we actually want to test. And we call it, and we get immediately the result. This is just within a milliseconds. You can run thousands of tests, testing every corner of your implementation, and it's still extreme fast. But we need a little bit more. Mocking some system away, we make expectation about behavior of this system. And if our expectations are wrong, then our test is not really available. So we have to check that external systems, especially complex external systems, behaves as expected. For example, database. Imagine we have a complex query. We need to be able to check this query against real database. So here is a persistence test, as I call it, and you can imagine it with any other external system that we just mock all but database away, and then we let our component call the database and get the results. And the important part is that we prepare our test by not calling the entire system, but just establishing objects in the database directly. And this is much more faster than integration tests, because there are not all these domain constraints in the way. We just need to satisfy database constraints in order to just create a couple of objects, and then we can run our query. So it's much faster than integration tests. Unfortunately, it's much slower than a unit test, but this is a price we have to pay. And actually, it's not a big deal. OK, so now let's turn to Xtend. And how many of you didn't familiar with Xtend? So probably heard, but not really. So a couple, OK. This is a very small introduction, and they will be learning by example, actually. So just this adds Xtend adds features to Java. That's why I find it a perfect match. We could take Ruby, but or just any other language, but there are two worlds that we have to switch between, and this is not good. Taking plain Java is horrible because we need to write a lot of boilerplate code, and you all know it, I'm sure. So Xtend is exactly what we need. We stay in the Java world, but we have modern language features that we can use. And I show you how. And this is a list of just a short list of most important features. We have type inference, we have extension methods, lambda expressions or closures, we have operator overloading. And you will see it in a minute how we can make use of it, and I will explain it as we go. So here is the first, our first snippet, and I will show a couple of snippets, and they will be a live demo with lots of code. I not intend you to fully understand up to each detail of those snippets. So just try to get an idea of those snippets, and if you want to know how it works, actually, then come later, and I will be happy to explain you that in details. So, but here we have very simple Java JUnit test, and this is the same test written in Xtend. So can someone find a difference? So there are a few, but not really a lot. So now you learned Xtend, and but we get to point where we have actually differences. So assertions is some kind of a central point of each test. And if you can C#, then you immediately say what the first argument, what the second argument is of this first assertions. So I cannot C#, that's why I'm wearing glasses. So I have to take a closer look to actually make sure what I'm comparing here with what. So it's not pretty good readable. We can improve it by just calling our assert equals using an extension method. And this makes it completely clear. Now it's, you see just the first argument, and this is what extensions methods are. We call it on first argument, passing second argument as a parameter. And this solves our problem. But we can improve it even further by defining an operator called spaceship, for example. And I prefer to have the expected value on the right, not on the left. So I swap in the implementation these two arguments here, and I can write my expected values on the right. And I think it's just totally cool. So now let's suppose we need a date that's 2 years ago in order to run some tests. And this is an absolute ugly Java code that we have to write time to time. In Xtend, it looks just like this. So you can't actually do better than that. And the cool thing is that this is not feature of Xtend. The feature of Xtend is allowing you to build those features yourself. By just defining those two methods, we build this feature. And you can ask everyone, they will say that's cool. So now suppose we have some data structure, and here we have books, and we have an application in the live demo about books. We have author and genre, and we set it just with some data, some test data. And again, you have to C#. It's not really clear what our data structure is. So we need to pay attention to each line to understand what the root object, what are child objects. In Xtend, we can do exactly the same in this way. So we're not just filling our structure with data, but at the same time, we're visualizing it within our program. And that's awesome. OK, now let me show you a new open source project that calls XFactory that can instantiate POJOs and entities. Entities that can also persist in the database. And the point is that we get objects filled with some reasonable data. And here's how it works. Again, learning by example. Suppose we need just instance of a book. Then we call xbuild, we pass instance of a factory, and we have a book. We can also persist it within a database by just calling xpersist. Because we have already reasonable data, so it satisfies constraints, database constraints, we can persist it. And we need it for our persistence tests, where we just have to prepare some database state in order to call our test method. But if we're interested in particular details of our objects, we can pass a closure, call minimal, and this will ensure that every constraint is satisfied within a database, and then we set a title here. And imagine having this code in your test, this focusing on what is important for your test. So this improves the readability of your test. All other attributes are set but not important, and so you don't have to write it. You can improve it even further by using domain methods. Here we have a book, and we need this book to be a bestseller. But we're not interested in details how to make a book bestseller within our system. So we just call this method make bestseller, and we get a book that is bestseller. And if the logic changes in the future, we just have to fix this method, and all our tests are green again. And this explains also how some authors managed to create bestsellers. OK, so let's see how we can actually write factories. And this is just ordinary classes, Xtend class, extending abstract XFactory. We implement minimal method, setting mandatory attributes. And here you can also see a marvelous way to specify dates in Xtend. So you can build this feature ourselves, so to let specify dates like this. And we also specify here the main method. So if you want author dead, then you just have to kill him. OK, and you can ask your neighbors. They will confirm that that's cool. And the last framework we need for our live demo is JMockit-Xtend. And there are actually two frameworks, JMockit and JMockit-Xtend. And why do we need it in the first place? So we need to mock external and internal components, so separated from our code under test. And this framework will help us. And this is a single example that I will show you. So this JMockit library is actually functionality of the mocking. And JMockit-Xtend is the integration of this library into Xtend. So you can just use these cool closures and everything else to configure your mocks. And here, first we define a class that must be mocked. And then using this start method, within a closure, we configure behavior that we want to have. So this method call is actually not a method call. No code get executed. It's just we say we expect this method to be called later, but don't do it, just return true. This is what's mocking about. And to confirm? So I think if you did mocking in a plain Java, then you will confirm that it's really cool, because it's a lot of boilerplate code you have to write. Okay, so let's go to start with live demo. And I have a wonderful library application that I prepared for this exciting event. And here it is. So this is Java Enterprise application. I have here a service layer, domain layer, data access object layer, and I have, of course, some tests. Integration tests, persistence tests, and unit tests. And we will be converting integration tests into unit and persistent tests. And we start here with this test. Just a moment. Oh. Okay. I have here a method that calculates average rating of a book for an author. So in the library we have books, and each book has a rating. And we want to know the average rating for a specific author. So we pass an ID, and we want to get this rating. And here, this is integration test. We have first to create author and then create a genre, because that's important. In order to be able to create book here, we create a couple of books, and then we call our method under test, and then we expect the rating to be something. And this test requires also a bunch of private methods here. So if something goes wrong here, the test is broken. So let's improve all this and write a unit test. But first I will show you the implementation. And the implementation is particularly bad designed, on purpose, of course. So here we combine call to external system together with the domain logic, which you actually shouldn't ever do. But we have code like this from time to time, so let's test it. And first you see that this call to the database we have to mock. And then we can test this logic. So let's do it. I prepared here just almost empty test with just call to our method that we want to test. And we're mocking here this book data access object that is used here. So this method doesn't get called. So let's start with configuring our mock. So I write just stop. Then I can call the method, and I pass the ID that I expect, and this is this 5. And then I say, okay, the result should be some list of books. So let's define the list of books, and in Xtend we can define a list like this. That's pretty cool. And then we have a couple of we need a couple of books. So we just call xbuild, then new XFactory book, and then we set, using a setter, we set rating to 1, and then we can copy it and say set it to 2 or 3, just like this. And that's it. So the average will be 2. Let's run it. Oh. And that's green. So never trust a test you never saw failing. Let's break it. We break implementation, run our test, and see that it's actually failing. So it tests something. And now we can depend on this test. So that's good. And look at this. We have just only important parts here. We have 2 books with rating 1 and 3, and we expect to get 2. And we have this some kind unpleasant part, but it's because of bad design. And no private methods involved here. So that's it. Now let's improve other tests. Another test. This is testing a method that just gives us 3 top-rated books in our library. So independent of the author, just the 3 top-rated books. And in order to test this, I start immediately here with some kind of hack, because we may already have some books in our database. And in order to test those methods, we need to first get a maximum rating that we already have, and then create books with even higher rating, so that the top 3 will be out of our new books, so we can assert our result. So we can make some expectations about result. So we first need this method, and then we create books, and there are also a bunch of private methods involved. And then getting result, we assert it. We say we expect 3 books, and IDs should be one with index 0, then index 1, then 0, and then 3. So it's not particularly good readable. So it's very simple, still 1 page, but in a real system, you can imagine this will become a mess very quickly. So let's improve it and write a persistence test. And why persistence test? It's because the entire implementation is within a query. We have here just a query that is sorting all books by rating, and then getting just first 3 results. So we need to test this query. And in this case, I will use Genero. This is, as already mentioned, a very great framework. It is like JUnit for Java. Genero is such a framework for Xtend. So it adds test features to Xtend. And here we read it like this. This is a definition of a class. This is a definition of a test method. And you can see this actually defines a method with a test annotation. So let's use it. You can first think of it as just plain Xtend. So first, let's say we define a list of ratings that we want to have in our test. This may be 6, 3, 8, 1, for example. And then we need books with those ratings. So we can use a functional programming side of Xtend and say we convert a list of ratings in list of books using using map method, and it gets a closure. This closure gets executed for each rating, and within this closure we create a book, and we persist it within a database, in the real database. And then we set the rating of the book to be R. So what does it mean? It converts the list of ratings into list of books and persists those books in the database. And we need to call here immediate copy in order to actually run this loop. And now we have all our books in the database, and we can assert it. And should be is a very cool assertion I show you. It's like our operator that we defined, but it's much cooler actually. So we need here a list of books that we expect. And let's first define indexes that we expect to get back. We expect here to get, let's see, 2, then 0, then 1, right? And here we just need to convert indexes into actual books. And we do it by just grabbing it from our list. So in case you wonder, I don't see, for some weird reason, a part of the screen on my laptop, so it's a little confusing, but I think this will work. So we convert the list of indexes into list of books, and then we assert it. So let's run it. Let's run it and see what we get. And it works. So first we have to break our implementation, of course, because green test does mean nothing. So let's reverse order of sorting. Did it lead to something else? Oh, okay. And we see that our test actually failing now. And now let's see what we have on information of from this assertion. So we have a bunch of information. This is because of this cool should be assert. It gets us not only two values that is not matching, but it gets us also the value of sub-expressions like this and like this. And we see that we see our indexes. We see our indexes mapped into the books. And we see also the books that we get from the database. So we can analyze our problem very well without need to rerun our test and add some logging or something like that. So let's fix it. And now our test is green again. And here our method is actually depends only on these two input parameters. So if we change those, we can build a lot of cool tests. So let's do it. And in a Genero, you can build such tables. And if I say table, I mean table. So let's draw it. We have a first column and second column. And then let's say we have here index rating 4, and then we expect index to be 0. And then let's take our actual example here. Oops. And we expect to get those indexes. So you write, just for each test that we want, we write a column. Then we can format it, and we have our different test conditions that we want to run. And then we have to iterate through those. We do it by just saying data for each, and then all this becomes a closure. And as you can see, this rating is used here, and these indexes are used here. So we can specify different tests and different test parameters in this nice way. So let's run it. And this will fail. Okay, I have here something. And it failing, but showing us a table with each row representing a test. This row was okay, but this row get an error. And we see under this one, actual the assertion. So this is also very nice reports that we get from those tests. And why actually this test is failing? That's because persistence test is built in this way that after each test we roll back all the changes. So we have always clean database. But here within a one test we run actually two tests. So we have old objects and we need just to clear our transaction, roll back and open a new one, and then we have green tests. So that's what you can do with Genero and Xtend. And now it's time for questions. Thank you very much. Yeah.
It looks very similar to Ruby, like all the abbreviations you have and possibilities. Was it inspired by Ruby? Or?
This was actually inspired by Ruby, I think, but this is like not a very big difference. There are just some modern languages that plays with different features of languages, and then it's just from many languages parts of that is was designed better and just looks cool. So yeah.
In your experience, if there is a project that's written in plain Java, is it difficult for the development team to write tests in Xtend? Or, for example, if they can't just start writing business code in Xtend for whatever policy reasons?
That's a very good question. So the question is it easy for a development team that is not familiar with Xtend or Genero to move to these techniques? And this turns out to be easier as expected. So in our project, that is, we're doing this for 2 years, I think, and it was extremely surprising also for me that we had almost no problems. So you don't start using all the features at the first day, but like in a month, you use almost all features already. And it's if you don't know some cool feature of Xtend, you just write it in a Java way. So Xtend let you write things as you used to do it. It's not a problem. Yeah.
And your actual productive code, is that then written in plain Java? Or?
Yes, our productive code is written in plain Java, and our tests up to 95% written in Xtend and Genero.
Why aren't you migrating the production code also to Xtend?
The entire project to Xtend. This is a management decision, so we have to use Java for some security reason, and such technology just has to little bit problems to get into the management layer, and some people think that Java is some kind safer, but we're allowed to use Xtend for testing. Yeah, please. Yes, we tried, but so the question was that the Xtend actually generates Java, so you can argue that you have a Java that actually produces your system or compiles to your system, but it's not worked. Okay, so we have no more time. All questions are welcome. I stay here, so you just come. We have a pause, a break right now, so I just stay for a couple of minutes. Every question will be answered.